Okay, let's go over number 11. It says that each day the trains are going to arrive in downtown Dallas from 7:10 to 12 p.m. and the first four buses arrive at the times listed in the table below. If the arrival times of the trains are equally spaced throughout the day, which of the following can be used to determine how many minutes after 7? That's the key. So you want the nth term, meaning write the rule, okay? And you want this rule to be based on how many minutes after 7. So be careful because it's not really talking about or needing the 7, the 8. It wants you to rewrite the table, and even though it didn't tell you, and put 10 minutes, because that's how many is after 7, how many minutes after 7, and then 25, because that's how many minutes after 7, 40, 55. But be careful when you put down your, let's make sure I did that right. Uh-oh, what should this be? 10. What should this be? 25. What should this be? 40. What did I do wrong? This is supposed to be the starting point. This is supposed to be the y-intercept. So should it have a 10 right there? No. So for 1, it should be 10 minutes. For 2, it should be 25. For 3, it should be 40. Awesome. For 4, it should be 55. And now be careful when you do number 5. It says 8:10. So do I put a 10 or is that an hour in 10 minutes? Now if you don't know how to do an hour in 10 minutes, you could look at the pattern here and say it's going up 15. So what would be 15 more? 70. Now remember, an hour is 60 minutes, so 60 plus 10 is how you get 70. And so I'm going to write this on this paper here since I kind of screwed that one up. So 10 minutes, 25, 40, 55, 70. Now, we have to find the rule based on how many minutes after 7. This is X, this is Y, this is X, this is Y. And we want to know what this would be. Well, if the pattern is 15 and we're going up 15, guess I should be writing in pencil, huh? This is going to be 15, and it's going to be positive 15. So what does this have to be so that when I add 15 to it, I get 10? Negative 5. And do you see a minus 5 or negative 5? And I know some of you are saying, well, I don't see 15x plus a negative 5. Well, what did we talk about when we said plus a negative? It is minus. The same thing as minus. So now do you see that? Yes, I see it here. Now why does it say n instead of x? It asks for the nth bus. So that's like saying the nth term. So it's going to have an n instead of an x. Alright, moving on. Number 12, we're going to take a look at the bends at the corners. You might want to call them edges, and section them off so we can see what's going on. Here I'm going to be still or stop. This is going down really quick and then this is coming back up. So can we find an A, B, C, or D that does what we see here? And we're talking about time versus speed. So, we're used to seeing distance versus speed versus time. And for distance, this would mean to stop. But does that mean stop for this? Why not? It's talking about speed. Oh, man. So how are we going to do that? What does it mean if this line is going this way and we're talking about speed? Well, it's talking about going the same speed for this amount of time. And then suddenly, coming down and slowing down your speed, and then your speed coming back up again. So, ooh, we almost messed up thinking we were talking about distance, didn't we? That's why you have to look at your independent and dependent variables. So letter A. A car quickly backs out of the driveway and then slowly increases. What do you think? Well, if you back out of a driveway, could you be going the same speed? Yes. And then slowly increases. Did it say anything about the speed dropping really quick? Because see, that's not a lot of time, so the speed had to drop, so no. Car pulls into Burger King and gets in a long line. Okay, that could be constant speed. And it moves forward and then stops. So, would you be driving into Burger King at a high speed? Because, you know, this is 0 down here. So, this must be pretty high. I would hope not, because you've probably hit the cars. A driver sees a deer cross the road and slams the brakes. Then he slows down and then gradually moves forward. Could this be the answer? Probably. Let's read D. The car is stopped at the stop sign. It then speeds up. It catches up with the tractor and slows down. And then it continues to follow the tractor. Well, it says that it's at a stop sign. And so most of you would pick this one as the answer, thinking that this right here means to stop. But it doesn't mean stop when you're talking about speed. It means stop when you're talking about distance. So be very careful about that. Okay, moving on. Which inequality best describes the range of this graph? So range is going to be from here to here. Can I draw that line right there? No, I cannot. Why not? Because you have an arrow. So range is going to be up or down, and of course it is up because my graph is up. And what number do I look at? -1, so I can eliminate C and D. And up means greater than, and I have a hole, so there is no line. The answer is A. Okay, moving on. Number 14 wants us to find the range. So the range is going to be from here to, can I draw this line? Yes, because there's no arrow, and it's 16. So 0 to 16 for range means Y. So this says 0 to 16. This says 0 to 16, and they are both underlined. So I just found a mistake that I will correct before you get your packets, because you can have two answers, but as you can see, they are exactly alike. So the range is from 0 to 16. I'll go ahead and make one of those X. Okay. Number 15. Iggy made a profit, P, off her last tour that can be represented by the function. This is the function. So $3,000 times N and subtract off 24,000. And N is the number of cities. Which is the best interpretation? So will she make a profit of $24,000? Well, it says minus 24,000. So I don't think minus means a profit, because profit to me means good stuff, positive stuff. So no. Let's look at letter C. Iggy needed to perform in more than 8 cities to make a profit. Well, what we're going to do is take 8, and since N means city, we're going to do 3,000 times 8, and then subtract off 24,000. So that's 24,000 minus 24,000, which is 0. Is that a profit? No, she comes out even, so it can't be that one. Now we're left with B and D. Iggy performed in more than 13 cities. If I'm performing in more than 13 cities, does that represent this information, the best interpretation of it? Unfortunately, not quite. If this had said Iggy performed in more than 13 cities to make a profit, maybe. But because that information is not given, this is not really telling me a lot. So Iggy made $3,000 a show. What do you think? Absolutely. This 3,000 is how much she made every time she went into a city. And that could be what this means in order for us to see her profit. Let's look at number 16. The first 5 terms in the pattern are shown below. So what did I do? Put my 1, my 2, my 3, my 4, and my 5 in my table. Made a space for 0. Found the pattern. It's going down by 4. So to go up by 4 would be 11. So look for the starting point at 11. That's here and here. Well, is 11 positive or negative? It is positive, and the only one with a positive 11 is answer choice D. And that is going down by 4. So the first number needs to be negative. The answer is D. Okay, let's look at number 17. The scatter plot below shows how much muscle weight is gained after a number of days of working out at a local gym. If the trend continues, what is the best prediction? What are trend lines used to do? Predict for the amount of muscle weight gained after working 92 days. So what I need to do is draw a trend line. The question is, where does it start? Can I start my trend line here? Is that in the middle of the information? No, it's not. So I probably need to start it maybe like that. Maybe. Is that okay? Follow my information. Okay, so now 92, 91, 2. Looks like I need to draw and extend my line a little more. And what does that number look like it's going to be? So this is how you use your trend line to predict. And based on the answer choices, it's higher than 5.7. It's 4.9 is too low. 7.1 is too high. 6.3. Okay, number 18. The average price of a movie ticket over a period of several years is shown in the graph below. What was the average price of a movie ticket in the year 2000? Okay, well, it says that this is the number of years since 1970. So this is 1970. This is 1980. This is 1990. So 2000 would be where it says the 30. And what would that be? Well, what do I need? Probably a trend line. So go through the middle of the data. Now, am I drawing this at 0? No, I'm going through the middle. The information starts at 1, so my trend line is going to be somewhere in between here. I'm trying my best to get it in the middle of that information. That's not bad. So it looks like at 2000, this is my answer. Well, how do I know? This says the average price in dollars right there. You can't see it, but when you get your papers, that says average price. And what does it say? Average price. So what is it really looking for? The Y value when X equals 2,000. So X is 2,000 right here. Go up, and this is your answer, and that is 5.5, which is B. So, what are trend lines used to do? They are used to predict. And when it asks you what is the average, meaning what is the Y value, you are predicting the Y value. And this is the Y. Okay, last question. A teacher